So we're going to make a generalization that is useful for when we get into series and differentials. Okay, not as useful for AB calculus, but it's very useful for when we get into BC calculus, okay, or calculus 2. So this generalization is going to be based on areas to the right of this curve, okay, so going this way and to the left going that way. And we're going to generalize this for powers greater than 1, or powers, and powers less than 1, in otherwise roots. Okay? And there's an opposite relationship when this happens. So if I take a look at this graph here, and let's say that we can choose some arbitrary starting point. Okay, we use 1, but it doesn't actually have to be any starting point. It could be any point on that line, okay? And if p is greater than 1, so for example, 1 over x to the power p, 1 over x to the power p, and where p is greater than 1, so for example, x squared, x cubed, okay, just like what we had here, okay, x cubed, what's going to end up happening is this area here is going to be finite. Okay, so we end up with finite area. And what ends up happening on the other side of that, if the area on this side is finite, the area on this side turns out to be infinite. We get infinite area on the other side. And so for powers bigger than 1, or like cubes, squares, and even higher powers, this is going to be true all the time. And now the reverse is true when the power was less than 1. And for when the power is less than 1, okay, so maybe I'll just summarize this here. So the part that we've shaded in blue is for this case, okay, for powers greater than 1. Just going to get rid of that, sorry. For when the power is greater than 1, okay, we're going to, from 1 to infinity, we're going to have this finite area in blue. From powers greater than 1, we're going to have that red area there, which is infinite. So from 0 to 1, okay, that area is going to be infinite. So there's this kind of opposite relationship here. Now we flip that relationship around when the power is less than 1. Okay, so I'm just going to do something different for powers less than 1. So let's kind of clean up this picture here. A similar relationship exists, but it works the opposite way around, because when powers are less than 1, the shape of the graph changes so that it pinches off to the asymptote quicker, and then it doesn't fall away quite as fast. So when we take a look at the area on from 1 to infinity on the right-hand side here, now that area becomes infinite. Okay, so this is infinite like that. And then on the other side here, this area now gets pinched off and it becomes finite. This area is finite. Okay, so we have finite area in that case. And that happens when the power is less than 1. For example, what we did was 1 over the cube root of x, okay, when we have root powers in the denominator. So we just kind of flip that relationship around when the power is less than 1. So to summarize then, if the power is greater than 1 under that black line, the area from 1 to infinity is finite. And the area from the asymptote to 1 is going to be infinite. And then that relationship flips over or switches when the powers are root powers less than 1.